Our next lesson is 7.5, solving problems with right triangles. So we're going to be using what we just learned about the sine, cos, and tan ratios to actually go ahead and solve some word problems in this lesson. So the first thing is to solve a triangle. So if a question in the textbook asks you to solve a triangle, it actually means they want you to find all side lengths and all angles. So if a question in the textbook says solve the following triangle, what they're actually asking you to find is all the unknowns, all the unknown sides, and all the unknown angles. So to do this, I usually kind of create like a little box in the edge of my paper. And I want to solve triangle ABC. So I know that my corners are going to be called ABC. So there's going to be 6 things that you're going to actually need. Some of them they're going to be given, some of them you're going to have to find. So in a triangle ABC, you're going to have angle A, angle B, angle C. You're also going to have the side lengths. And the side lengths, the letters that you use are actually the lowercase. So if you see a capital letter, that's always talking about an angle. If you see the lowercase, this is the side lengths. So side A, side B, and side C. So we're given a few things here. I'm given that angle B is 90, so I already know this one. Angle A is 72. And the side length B is 10 centimeters. So right away, I just kind of write in my box what I already have, and then I can just plainly see what I need to find. So let's go ahead and draw this triangle. If I know angle B is 90 degrees, so I have a 90-degree triangle. I'm just going to draw a 90-degree triangle. Again, it doesn't matter what it looks like. It doesn't have to be drawn to scale. So as long as we have a 90-degree triangle, that's good. Angle B is 90, so I know this is big B. That's 90 degrees. Angle A is 72, and again, we're just going to pick an angle here. I'm going to call this one A, and I know that's 72. Now, if you were doing this on your own or you had a textbook question like this, you could call the other angle, angle A, and label that as 72. You're going to end up with the same answer. And the other piece of information we have is B is 10 centimeters. So you need to figure out what side is actually little b. So here's how you do that. When you're labeling, your capital letters are always across from your lowercase letters. So across from big A is little a. Across from big B is little b. And the side that or the angle we don't know here is C, because this is triangle ABC. So across from big C is little c. So that's how you're going to label your sides and your angles. So the piece of information that they're giving us is little b is 10 centimeters. So this side length here is 10 centimeters. Okay, so that's all the information that we're given. We need to go ahead and find what I have in this box here. We need to find angle C, we need to find little a and little c. So the first thing I'm going to do is find angle C. And I always kind of write down what I'm trying to find so that when my teacher marks it, she can follow my thought process here. So because I already have 2 angles in the triangle, if you look over here, I already have 2 angles. How do you find a third angle? So try to remember, what do all the angles in a triangle add up to? And it would be 180 degrees. I know that all the angles in a triangle add up to 180. So you guys learned that last year in grade 8. I'm pretty sure you've talked about that before. So if I wanted to find angle C, I just have to take 180 and subtract all the other angles. So I know one is 90 and I know the other one is 72. So if I take 180 and subtract those, you're actually left with 18 degrees. So I know C is 18. I'm just going to fill it in my box so I know that one's done. And the other 2 things that we need to find here are little a and little b. So I'm going to write down, I know this is 18. Okay, so the first thing I'm going to do is find little a. Find a. All right, so when you're given a triangle like this and you're asked to solve for this stuff, you always want to go back to the stuff that you're given. So when I'm going to use these trig ratios to find some side lengths here, I always want to go back to the angle they actually gave me, which was the 72. So I'm going to be using the 72 as my angle of interest. That's just in case I make a mistake with angle C. If I kind of did my subtraction wrong or entered it wrong in the calculator, you don't want all your other questions to be wrong as well. So I'm just going to go ahead and use what I was given. So if I have that 72 there and I'm going to label label the sides of the triangle according to that angle of interest. So across from my right angle will be my hypotenuse. Across from my angle of interest will be my opposite. And the other side is my adjacent. Okay, so I'm using my 72 as my angle of interest because that's the angle that they gave me. So when I look for little a, I can see little a is going to be my opposite. And I'm also given the hypotenuse. So I know I want to use the hypotenuse. So when you think of Sohcahtoa, we have to choose the correct ratio here in order to be able to solve for little a. So in order to solve for little a, I'm going to use the hypotenuse because they gave it to me. And a little a is my opposite. So we're looking for opposite and hypotenuse. So you're going to look across Sohcahtoa, look for the O and the H, opposite and hypotenuse. So that tells me I'm going to be using my sine ratio to solve for little a. Okay, so your first step is to write out the ratio. You get a mark for writing the right ratio. Sine theta is O over H. You're going to plug in your unknown values, or sorry, your known values in this case. Theta is 72. My opposite is A, so I don't know my opposite, but I do know how my hypotenuse is 10. So I'm trying to solve for little a here, which means I need to get a all by itself. In order to get a by itself, you're going to take that 10 and multiply it on the other side. So we're going to have 10 times sine 72. And again, get your calculators out and actually try this. Try punching that into your calculator. So try 10 times sine 72 and hit equals. Again, if you don't have your calculator, pause this. Go grab your calculator. If you have a backwards calculator, don't forget you're going to be hitting 10 times 72 sine. So try this in your calculator. Make sure you get an answer of 9.5 centimeters. So since I know A is 9.5, I'm going to write that in my box here. I got that checked off. And your last thing here is to find little c. So we're going to be finding little c. And I'm going to be looking back at my triangle and the side lengths that I labeled, opposite, hypotenuse, and adjacent, to try to figure out which ratio am I going to use now. So I'm going to have to use a different ratio because I'm finding a different side. So I'm still going to use my 72. I'm still given the hypotenuse, but this time I want to find the adjacent. So when I look at Sohcahtoa, I'm trying to find the adjacent, and I'm given the hypotenuse. So you're looking for the A and the H. So you look across Sohcahtoa, and your A and the H is with the cos. So we're going to be using the cos ratio. I'm going to write that out, is A over H. I'm going to substitute what I know. So I was looking from the angle of 72. I'm trying to find my adjacent, and I know the hypotenuse is 10. In order to get C all by itself, we're going to take that 10 and move it across. So I'm going to end up multiplying. And then you're punching this in your calculator. 10 times sine 72. Oops, cos. Sorry. I'm sure you guys are screaming at the screen. This one's cos. Okay, 10 times cos 72 equals, and that's going to be 3.1 centimeters. Make sure you fill that in my box. So I have all the angles and all the side lengths. You can see how easy it is to mix up those ratios. I started with cos and then I changed it to sine in my head. So make sure you watch that. This is a key piece of information for word problems. A lot of word problems talk about angles of elevation or depression. So those might be new words to you. Elevation kind of makes sense because we do talk about like elevators and things elevating. We hear that word a lot. So angles of elevation and depression are always measured from the horizontal. So you're always looking out from a horizontal line. Again, horizontal is going across like our x-axis does. So angle of elevation is always from the horizontal looking up. So angle of elevation is always from the horizontal, looking up. And you're going to find that one's pretty easy. When you see the angle of elevation in a word problem, that one you know how to label. It's always from the bottom looking up, or the horizontal looking up. It's this other one that's kind of new that we don't hear this a lot. It's called the angle of depression. Angle of depression is from the horizontal looking down. So looking down. And this one's difficult because if you're given a triangle that looks like this, When they give us the angle of depression, we always want to put it here, and that's not what it is, okay? So angle of depression, if you have a triangle such as this one, it's always from the horizontal looking down. So when they give you an angle of depression of say 23 degrees, they're actually telling you that this angle in here is 23 degrees. So in order to use it with our triangle, we would need to figure out the complement angle. So you would take, this one would be 90 minus 23. So angle of depression is from the horizontal looking down. You could also think about this as the Z pattern. So you guys looked at the Z pattern in elementary school and last year. If you look at the backwards, actually this is not a backwards Z, it's a frontward Z. If you look at the Z pattern here, if this angle is 23, this one would be 23 as well. So now you have an angle inside your triangle. So when you're trying to solve things, you want an angle in your triangle. And when they tell you it's an angle of depression, they're trying to give you that information to find it, but you need to do one extra step. Okay, so just be careful of that angle of depression. Again, if you ever run into a question, you're not sure if you labeled the triangle right, you can always email me to ask me. So let's look at a couple of examples here. From a point 28.5 meters from the base of a cliff, a land surveyor uses a theodolite to measure the angle of elevation to the top of the cliff as 73.5. What's the height of the cliff to the nearest tenth of a meter? So we're talking about a cliff here. Here's my cliff. It's ragged, it's rocky. From a point 28.5 meters away from the base, so we're looking from here, this is 28.5, there's some guy standing there, 28.5 meters. The angle of elevation, so the angle from the horizontal looking up, is 73.5 degrees. Again, it's not going to be to scale here, but this would be 73.5 degrees. And the question is, what's the height of the cliff to the nearest tenth of a meter, so 1 decimal place. So this is kind of what my diagram would look like. You get a point just for drawing a diagram if this was on an assignment or a test. I want to label my opposite, adjacent, and hypotenuse from the angle of interest. In this case, it would be from the angle of 73.5 degrees. So from that angle, this would be my opposite. My hypotenuse would be across from my right angle, which is against the cliff here. And then obviously the other one would be my adjacent. So what ratio am I going to use? Well, I'm trying to find my opposite, and I'm given the adjacent. So again, this question is not asking for the hypotenuse, and it's not giving it to me, so that actually doesn't pertain to this question. You only need to use 2 of these sides. And in this case, we are using the O and the A. So you're going to be looking across for the O and the A, which is at the end here with TOA. So you're going to get a mark for writing out the right ratio. Right ratio is the tan ratio. So tan theta is opposite over adjacent. I want to sub in everything I know. So this time I know my angle. The opposite is x, and I'm trying, oh, nope, the adjacent is 28.5. Sorry, subbing in 28.5. So I want to get x all by itself, which means I need to move that 28.5 over to the other side. So we're going to end up multiplying 28.5 over here. So in your calculators, you're going to be typing in 28.5 times tan 73.5, hit equals, or the backwards calculators, you're going to be typing 73.5 tan times 28.5. I'm going to tell you that your answer should be 96.2, so make sure you can get it into your calculator so that your answer is 96.2. I left it as 1 decimal because it told me to round to the nearest tenth. And because it's a word problem, I would write a therefore statement. So the question was, what's the height of the cliff? So therefore, the height of the cliff is 96.2 meters. Okay, so I got my diagram, labeled it correctly, solved, got the answer, and I wrote a therefore statement. This is what I'm going to be looking for. We're going to do 2 more examples. A hot air balloon on the end of a taut 95-meter rope, that just means it's like a tight rope, it's not bending, okay, rises from its platform. Sam, who's in the basket, estimates the angle of depression. Angle of depression to the rope is 55 degrees. How far to the nearest meter did the balloon drift horizontally? Okay, so we need to draw a diagram here. A hot air balloon is on the end of a taut 95-meter rope, rises from its platform. So let's say the platform is here. Platform. Sam, let me just draw a basket here. Got some strings and a balloon. Mrs. Westling, the artist. All right. Okay, so Sam's in the basket. He measures that the angle of depression to the rope is 55 degrees. So don't forget, when it says depression, you're looking out from the horizontal. So Sam is looking out from the horizontal down. And down, sorry. That is 55 degrees. How far to the nearest meter did the balloon drift horizontally? So we actually want to figure out this length here. How far has it drifted over? So this is my x. Okay, and really this line should come down where these two cross. Make your triangle. Okay, so I need one other piece of information, and that's that the rope is 95 meters. So this here is 95 meters. And the question is finding x. So let's do some labeling here. From 55, this would be my opposite, which we don't need. I'll label it anyways, opposite. This one would be my adjacent, which we do need, and this would be my hypotenuse across from my right angle. So which two am I dealing with? I need to find my adjacent. I'm given the hypotenuse. So if you look at Sohcahtoa, which one has the A and the H? So we're going to look across. That would be cos. So what you're going to do is write out your cos ratio. Cos is A over H. And we're going to sub in everything we know here. So I know my angle is 55. My adjacent is x, and my hypotenuse is 95. I want to get x all by itself, so I'm going to take that 95 and move it over. Which means we're just multiplying. So 95 times cos 55. Try that in your calculator. Try punching it in. If you have a backwards calculator, it's 55 cos times 95. And because I'm rounding to the nearest meter, my answer is actually 54 meters. Make sure you can get that answer. If not, take a pause and try to figure that out. And it's a word problem, so I'm going to have a therefore statement. So I'm just going to read the question again. How far did it drift horizontally? Therefore, the balloon drifted 54 meters horizontally. I always take a minute and just reread the question just to make sure that I'm answering it properly. And the last one's the tougher one here, and this one always pops up. I always see these on in the textbook, and on a test it may pop up. You never know. A video camera is mounted to the top corner of a 120-meter tall building. The angle of elevation from the camera to the top of a neighboring taller building is 17 degrees, and the angle of depression to the base of the taller building is 25. So what they're telling us here is there's two buildings. So the first thing I'm going to do is draw my two buildings. It states that one is taller than the other. So think of this like New York, big skyscrapers, or Toronto. We got two buildings here. I'm just going to reread it. A video camera is mounted to the top corner of a 120-meter tall building. So I know that the 120-meter tall building is actually the shorter one because it goes on to say that there's a taller one. So I know this is 120 meters tall. And there's some camera that's on top of there. The angle of elevation from the camera to the top of the other building is 17 degrees. So if I connect these two, this camera is looking up. So elevation is from the horizontal looking up. That is going to be 17 degrees in this little triangle here. And the angle of depression to the base of the taller building is 25 degrees. So if we look from that camera to the base of the taller building, the angle of depression, which again, depression is from the horizontal looking down. So that is 25 degrees. The question's asking us how far apart are the buildings. So they're giving us a bunch of information here, and we need to figure out, our first job is to figure out this value, x. How far apart are the buildings? So we need to pick a triangle out of this and to try to figure out the side length of x. So what I'm going to do is I'm going to pull out this triangle. I'm going to outline it here in black for you guys. And I'm going to pull this out. So I like to just redraw it so that I leave out all the other stuff and I just have my important pieces of information. So I know this is 120 meters. I know I'm trying to find this value here. And I need some other piece of information. Either I need the side length for the hypotenuse, so I can use Pythagorean theorem, or I need an angle in there so that I can use the trig ratios. So you need to look at the angles that you're given and try to figure out how are you going to find an angle in this triangle. So what I'm going to do is I'm going to use the fact that this makes a right angle here. If I know one of these is 25, what does the other one have to be? So a right angle, the angles always add up to 90. So if I want to know this angle here, I'm just going to take 90 and subtract that 25. So 90 subtract 25 is actually 65. So I know the angle in that triangle is 65. Okay, now I can use my trig ratios. Now I finally have an angle. So let's go ahead and label them. This is my hypotenuse. Across from my angle of interest, or the angle we're given, is my opposite. And the other side is my adjacent. So which two do we actually get to use here? Well, I'm trying to find my opposite. I'm given my adjacent. So we have O and A. So some of you guys by now have can kind of put Sohcahtoa in your head and figure out which one you're going to use. I'm going to write it down just so we can see it. We have O and A. So you're going to look across, look for the O and the A, which means I'm going to be using the tan ratio to solve this. So I'm going to write that out, get a mark for that. Fill in what you know. I know the angle is 65. I know the opposite is x, so I guess I don't know the opposite. And the adjacent value is 120. So you're trying to solve for x. We're going to take that 120 and move it across, which means we're just going to end up multiplying those together. So make sure you can punch that into your calculator. And it's actually 257.3. So how far apart are the buildings? Therefore, the buildings are 257.3 meters apart. So make sure you're answering that question. Part B wants to know, how tall is the taller building? I know the shorter building's 120. How tall is the other one? So when I look at that, I could try to create a big triangle, but I wouldn't know any angles. So when I'm looking at this, I see this red triangle. Do you see this red triangle here? I have that triangle. If I can find this value here, let's call this y. If I can find this value here, I already have this side. This is an x, but I already know this. How tall is this one? Just like the other side, right? This is 120. I already know that's 120. If I can find the value of y, I can just add those two together and I'll have the height of the taller building. So let's pull out the red triangle this time. So we're looking at a different triangle. And I'm going to kind of label everything I have here. I want to figure out this value y. Oh, I know that this is 17. I need some other value. Either I actually need a side length. I need another side length. So I can't find the hypotenuse here, but can I find this bottom value? If you look up at that top diagram, the bottom of that red triangle is actually the same as the x value. Luckily, we know the x value because we already figured that out in the previous question. So I know this bottom value is 257.3. Okay, that's all I need. If I have an angle and a side, I can find my value for y. So which trig ratio are we going to use? Let's do some labeling from the angle here. Here's my opposite. Here's my hypotenuse, and my last one is always my adjacent. If I'm looking at what I'm trying to solve for, I need to find the opposite, and I'm given the adjacent. So in Sohcahtoa, what ratio is that going to be? Which one are we going to be using this time? So O and A. You're going to look across. You're going to be using the tan ratio this time. So tan is O over A. I write it just in the same order that I see it. I'm going to sub in everything I know. So I know my angle is 17. My opposite value is y. That's what I want to try to find. And my adjacent is 257.3. So if you want to get y all by itself, you're going to take that 257.3 and multiply it on the other side. And then you just plug in that into your calculator. Plug that in your calculator and see if you can get the right answer. I'm going to tell you the answer is 78.7, so just plug that in, see if you can get that. Might have to try a couple times. Don't forget that is just that top portion of the triangle, so if I want to find the full height, I'm going to have to take the height of the smaller building, which was 120, and add that extra section on that we just figured out, 78.7. So we're going to have to add those together. We get 198.7 in total. So therefore, the height of the taller building is 198.7 meters. So when you're doing these questions, sometimes you are going to have to find little pieces of information and add them together. Sometimes you actually end up doing some subtracting. So make sure you read the question really good. Try to draw a diagram. Diagrams always help. There's the questions that you're going to be working on. Again, that's in the binder section of the content area. It lists these questions, as well as my website, as well as in the announcement section on D2L. It shows you which questions you should be working on. Check the answers in the back. Okay, I can't stress that enough. Check the answers in the back. Make sure you're getting those right. If you're not getting them right, stop and email me. Let's clear up those issues before you move on to the more difficult questions. Okay, I'm here to help you. Don't forget that. Make sure you're emailing me if you have any questions. Okay, good luck with that homework there.